Objectives and goals, well, I think there are many of them, but the most relevant are here. I always struggle selecting pertinent goals, so I don't know how when you start a book related to mass transfer, they select very properly a goal. I think there are many goals or objectives that you can cover, even if you don't write them. But anyways, let's check out the main goals. So first things first, understand the principles behind unit operations involving vapor-liquid phases. So for me, it will be great if you understand the mass transfer principle, which governs gas absorption, distillation, the humidification, drying, etc. If you do that by the end of this course, I will be more than glad. Stated before, not only that, if you understand them, that will be great, but also, why not, you should know which industrial applications are going to be based our principles: distillation, gas absorption, stripping, scrubbing, and so on. We're going to present them later on, make no worries, this is not the final list. Model molecular diffusion via Fick's law and its common cases. So of course you will need to understand what's molecular diffusion, how it works, why do we use Fick's law, what does it mean, how to use the equation, and the common cases, because as you know, these are very crazy laws which you can apply to very crazy cases, but the most common one, unimolecular diffusion and equimolar diffusion, are going to be the ones that we are going to be presenting. Know the relevance of equilibrium and mass transfer. So I think there is, okay, for instance, there might be an equilibrium and there might be no mass transfer, and the reverse is never true. So in order to have mass transfer, you gotta have no equilibrium. So if you have equilibrium, there will be no mass transfer. We're going to cover that later on. Understand correlations for mass transfer cases and why they are used in engineering applications. So as stated before, several mass transfer correlations for, I don't know, pipes, cylinders that are vertical, maybe even spheres. If you're talking about flow outside transversally of a pipe, maybe you're talking about inside the pipe. We have all those correlations. A wall, let's say this is a solid and this is a liquid and this is a gas, there will be an interaction. There are many correlations that we're going to be covering. Understand the importance of films and interfaces. So what is a film? Well, you can imagine it's a very small, let's say, laminar layer in which there will be exchange of mass. And interface is nothing more than the connection, or I will say I don't know how to say it, but when you connect a gas and a liquid, there is an interface because you have two phases. Learn about the different theories behind interface mass transfer. So as you can imagine, there are plenty of theories that will try to model these, though some theories are, let's say, presented so you can model it easily, even though you know that real life is not easy. So as time passes by, there are plenty of studies that try to improve the model of these theories, so the theories get a little bit more complex, more hard to use them as engineers. Yet, of course, what we want is to model properly. Solve common engineering problems found in gas absorption and distillation, and of course, any other gas liquid or vapor liquid operation. So you see me a lot saying gas liquid and vapor liquid. We're going to cover why these are not the same. But for now, just try to assume that gas and vapor is not 100% the same.